Why does Gibbs free energy change with pressure and concentration? Have you ever wondered why some chemical reactions happen more easily under certain conditions? One of the key players in this process is Gibbs free energy. Let's break down how pressure and concentration influence this important concept. Gibbs free energy, often represented by the letter G, tells us about the maximum useful work that can be obtained from a system at constant temperature and pressure. It is calculated using the relationship between enthalpy, entropy, and temperature. The formula is G equals H minus T times S, where H is enthalpy, T is temperature, and S is entropy. Now let's talk about pressure. When pressure changes, it affects the volume and energy of a system. For gases, increasing the pressure pushes molecules closer together, which raises the energy of the system. This means that Gibbs free energy typically increases with pressure for gases. For liquids and solids, the effect is smaller, but it still matters. Changes in pressure can influence how molecules interact and how phases of matter balance out. Next up is concentration. This refers to how much of a substance is present in a system. When the concentration of a reactant or product changes, it alters the chemical potential of each species involved. Chemical potential is essentially the partial molar Gibbs free energy, and it is directly related to concentration or partial pressure. When concentration increases, the chemical potential changes, which in turn affects the Gibbs free energy of the entire system. This relationship can be expressed with the equation. Change in G equals standard change in G plus R times T times the natural logarithm of Q in this equation. R is the gas constant, T is temperature, and Q is the reaction quotient that reflects the concentrations or partial pressures of the reactants and products. So what does this mean in practical terms? The spontaneity of a reaction, or whether it will happen on its own, depends on the pressure and concentration conditions. For instance, if you increase the concentration of reactants, you can lower Gibbs free energy, making it more likely for the reaction to occur. Similarly, altering the pressure can shift the balance of reactions involving gases, in line with Le Chatelier's principle. Understanding how Gibbs free energy changes with pressure and concentration is essential. It helps us predict and control chemical reactions, phase changes, and biological processes. This knowledge is particularly important in fields like chemical engineering, biochemistry, and environmental science, where managing reaction conditions is key to achieving desired results.